Okay, we're going to evaluate expressions with rational exponents. So if I'm given something like 16 to the 3/4, I can rewrite that as a radical. I just have to remember that if I look at my root, so my root is what goes right here, right, this part right here, this is my root. That my root is like a root on a tree, that it's going to be, at the bottom. So it's going to be my denominator right here. This is 4. So my root goes in here. Okay. And that I have left over is this 16 to the power of 3. Okay. Well, I can look at that and say I can factor my 16 and think about it in terms of a common base. So why don't I do this and say, well, I want to know what 16 factors to, and it factors to 4 times 4, which can factor further to 2 times 2, and then 2 times 2. And I can rewrite that, and I'll rewrite this whole thing again and say I've got a fourth root of something to the third, and that something is 2 times 2 times 2 times 2, which is really 2 to the fourth. Okay, so these are the same. And so what I've done now, so I'm going to make sure I make this clear. So what I've done now is I've taken my 16 and I factored it and I rewrote it here. Okay. Now I'm going to use my power to power rule, and that is if I have a common base or a base and I want to do my powers to powers, I multiply them. So this is going to be the same as having the fourth root of 2 to the 4 times 3. And this is the same as saying I got the fourth root of 2 to the 12th. Okay, so if I'm looking at it in terms of a radical, this is a way I can look at it. And I'm going to rewrite that into a power. And I can say, well, that's the same as saying I've got 2. And then I'm going to take my root, I'm going to write it in the denominator and say, well, that's going to be 4 in the denominator. And then my power is 12, so that's right here. I'm going to put that right here in the numerator. And I can do my division and say 12 divided by 4. Well, 12 divided by 4, well, that's going to be 3. And 2 to the third is 2 times 2. This is really 2 times 2 times 2, which is 8. So that's how I can do that one. I can do the same thing again with this 27 to the 4/3. Again, I'm going to rewrite this and say that I know that my root is what goes down here into my root, so that's going to be a 3, and that I have 27 to the 4th. And I can look at my 27 here and say, well, my 27, I can factor that guy out and say, well, 27, I'm going to go like this so I can kind of keep this a little straight. 27 is the same as 9 times 3, which is the same as 3 times 3 times 3. So I can rewrite my 27 in terms of a power and say, well, that's the same as saying I've got the cubed root of something to the 4th, and that something is 3 to the 3rd. Right, that's this guy right here, so my 3 to the 3rd is this stuff right here. And then I can do my power to power rule and say that I can say this is the same as saying a 3 to the 3 times 4, which is 3 to the 12th. And then I can rewrite this and say, well, I know that my root is going to go in the denominator, so I can say that I can put this in a denominator. And so I'm going to go, I have my 3 and I have my denominator of 3 and my power of 12, and I can reduce that fraction and say that's the same as saying that I have 3 to the 4th, and that's the same as saying that I have 3 times 3 times 3 times 3, and that's 9, and that's 9, and 9 times 9 is 81. So that's going to give me my answer for that one. So 81. Okay, so that's one way to look at it. And I'll put this little squiggly line so I sort of keep everything a little organized. Okay. Another thing I could do, so I can look at it as a radical. This is one way to look at it. So here's this guy. We looked at it as radicals. And then the other way I could look at it, I can look at it using this power to power rule from the get-go. So that's another way to look at it. And I could say that I can break this into power to power. So let's suppose that I want to say I had something like this. I had 16, and it started out with a 1/4, and then I said to a power of 3, and if I did this power to power rule, so if I did the 16 to the 1/4 times 3, I would get 16 to the 3/4. Like that's where that came from. So I'm going to erase that, but that's where it's coming from. So if I look at it that way, I can start to deal with the stuff inside the parentheses. So I can say, well, I'm going to look at this stuff right here, and I can write my 16 into powers. So I'm going to say I have this 1/4 here, and I'm going to do my 16, and so 16 is 4 times 4, which is 2 times 2 and 2 times 2. So I'm going to have this 2 to the 4th, and I can do a power to power inside here. So this is power to power right here, and say that that's going to be 2 to the 4/4, and then I still have my 3 over here. And that's going to be the same as 2 to the 1 and my 3 over here. And my power to power says I multiply my powers, and I get 2 to the 3rd, which is 8. Okay, so that's just using my power rules. Or I can do my 27. I can look at it the same way and say, well, I'm going to treat my denominator as one piece and say, well, this is really 27 to the 1/3, and the power of 4 to the 4th. So I'm breaking it into two pieces, my 3rd and my power of 4. Another way I can look at this, instead of breaking it down like I did over here, so over here I said I'm going to just break that 2 to the 4th, down to 2 to the 4th instead of 16. I could look at this and say, well, maybe I can look at that and say that's just the cubed root of 27. So right here, this is just the cubed root of 27. And the cubed root of 27 is 3. So that's another way to look at it. And so I could replace my 27 to the 1/3 and say, well, that's the same as saying that I had something to the 4th, that this something happened to be 3. And I can say that 3 to the 4th is going to be the same as 3 times 3 times 3 times 3, and that's going to be 9, and that's going to be 9, so 9 times 9 is 81.